Want to look at the proof for Laplace transform of sine bt of sine. Okay, proof of Laplace of sine bt. Okay, so let's see that proof of that. We know the definition that the Laplace of a function limits as n tend to infinity from 0 to n minus xt dot my f of t is equal to sine bt dt. Okay, don't forget our formula. Laplace transform formula is this: integral from 0 to infinity of exponential dot f of t dt equal to limit as n tends to infinity from 0 to n. Okay, this f of t dt. So that's what I'm using. This is the final conclusion. So your f of t in this case is what? Is a sine bt. So if you look at very well, this is a product 1 and 2. Okay, so we're going to use for this integration, we're going to use, we can take that integration out. This integral, we can take it out from lower boundary to upper boundary. Let's take that out and use integration by parts. Let's use integration by parts, where u is going to be this, and the v is going to be sine bt. My du is equal to this, then times, in differentiation is times by the attachment of that variable. The variable is t, so minus x. Okay, then integrate the v is this, the t. Okay, so your v will be equal to, if you integrate sine, then that will give you cos bt all over the attachment of that function. The function is t all over b, but integral of sine is minus. Okay, sine bt. So then I'm using this formula uv minus v minus this uv minus v du. So that's what I'm using. So this is my uv, multiply these two, uv, which will be equal to minus 1 over b e st cos bt, then minus integral of v, which is the minus cos bt over b, then the u. The u here is this, the t. Okay, so we can bring it together, and that's minus x dt. So we can bring this constant s and b out. Minus times minus, that's a plus. So we now have 1 over b st cos bt minus this times this, and bring this one out. That's x over b integral of e minus st cos bt dt. So we have that. Then don't forget our question. Our integral is this. That's our integral, which is integral from 0 to this. This one. Yeah, that's our integral. Okay, let's leave the upper and lower boundary for now. Then, and that one is giving us minus b 1 over b e st cos bt minus x over b integral e minus xt cos bt, bt, then dt. Okay. So this one also we have here. We're going to apply again integration by parts also. Okay. So where u will be equal to, don't forget here, I mean this one, where u is this, and then the v is equal to cos bt t. So the u is equal to minus, we differentiate this, we give it its function, then times derivative of the power. Our function is t. So times the attachment of t, which is what? Minus x. Then integrate this one. So v is equal to what? Integral of cos is sine bt. Okay, then you divide by what? Attachment of the function, which is b over b. Okay, so we now have our integral. Can we call this one? This is our integral. Can we call it I because of space? Let's call this one I. Let's denote this one as I. Okay, I equal to minus 1 over b e st cos bt minus x over b. Open the bracket now. Uv. My uv is uh, 1 over b e minus st sine bt. That's my uv. That's my uv. Then minus integral of v, which is what? Sine bt over b times du. My du is what? Is this. This is my du. That's a minus minus xe dt. So I can close this open bracket here. I can close it here. Okay. Then I will now have I equal to minus 1 over b e st cos bt minus x over b into brackets 1 over b e c sine bt. Here, minus is there, minus is there. That's plus. Now we got to this x can go out. This x, you can take it outside. That's x over b integral of sine bt that will be equal to e minus st sine bt dt. Then equal to just minus 1 over b this cos bt. Okay, then open this bracket. Open this bracket. This is a big bracket here that I open here and closes here. So this fraction x over b times 1 over b, that will be minus x over b squared. Okay, e minus st sine bt Then minus also here times this one, that will be minus what? That will be minus x squared over b squared integral of what? Integral of e minus xt sine bt. Okay. And then if you check now, you now see that this integral here is the same as our question, which is I. This is the same as our question. In that case now, we can move this one to go and join this I here. Okay. So that will now give us, I will now have, if you move that one to other side, to left hand side, we now have, we have I plus, that's for the integral, plus f squared over b squared I. This integral is what I'm calling the I. I'm using the symbol I for that, okay, which is the same as our question. And when you move the negative to the other side, it becomes plus. So we have this, Okay, and we can solve this. If we solve this, this will become I plus. You can take the I out. If you take it out, you have 1 plus s squared over b squared. And that will be equal to I into bracket this one times this one, that's b squared plus s squared over b squared. So that's what we're going to have on the left hand side. And that is equal to, minus b, minus 1 over b, e st cos bt minus x over b squared e minus st sine bt. So that's what we have now. That's what we have. If you want to remove this fraction, what do we do so that it will remain I? We want to make I to stand alone, which is our question, which is the integral. Okay, then we have to use the inverse of this expression to multiply both sides. So I will now will be equal to b squared over b squared plus x squared. Okay, and then times minus 1 over b e minus st cos bt minus x over b squared e minus st sine bt. So that's what we have now. We just allow this one to go in that expression. We allow that to go into that expression. What we do now, we now have I equal to b squared over b squared plus x squared. Here, something is common here. 1 over b can be taken outside. So we have 1 over b can factorize that. 1 over b can be outside. That will be equal to minus e st cos bt minus x over b e st sine bt. We close it. Okay, and you can multiply. If you take it outside, if you take this 1 over b outside, then you now have b over what? B squared plus x squared into bracket what? Into bracket minus this cos bt minus x over b e minus this sine bt. Okay, so that's the integral. Then the next thing to do now, so integral of this from 0 to infinity of the question sine bt dt will be equal to integral from 0 to that will be equal to limit as n tends to infinity of that integral from 0 to n. And we have the value already. Let's just that will be limit as n tends to infinity. We have the integral, which is a b over b squared plus x squared e minus st cos bt minus x over b this sine bt. Okay, then we can now put the upper boundary n and lower boundary. So we can substitute now. We can substitute that, and that will be equal to limits as n tends to infinity. We substitute. We have b over b squared plus s squared into, for the upper boundary, we have minus xn cos bn minus x over b e minus n sine bn. Okay, that's the upper boundary. Then minus the lower boundary. You can close like this. Minus the lower boundary. Put 0 there. If you put 0 there, sine 0 is that one is gone for the lower boundary. This will go. when t is 0. Then here you have minus is here, so minus 1 minus this one here become what? Plus 1. So you have that. Okay? And don't forget that limits as n tend to infinity of this function minus this xn cos bn is equal to limit as n tend to infinity x over b xn sine bn. Okay, and they both equal to what? They both equal to 0. But don't forget that limit of negative infinity is what? Is 0. Okay, x times infinity, that's infinity, so that's 0. Okay, so that's that, and you now have the only thing that will remain now is just your constants, So you're proving now, your answer will now become b over x squared plus b squared. Okay, and that is that is for the Laplace of what? Laplace of sine bt, which is what? B over s squared plus b squared. It's a little bit long. It's a little bit long where the x is greater than 0. Okay, it's a little bit long. Okay, we use integration by parts for that.